But I wonder, like, maybe Dhruv and Devi, if you look back at the original VQA, and if someone had told you that you had a machine now that could get 80% accuracy, um, where would you think we would be as a field of AI in general if we had that capability?
Yeah, I think that's a very interesting question, and not a direct answer to it, but we have been looking at collecting like these adversarial examples where a person is interacting with the model to find questions where the model will fail. And it's actually not that hard to find them. Like if you try like on average, I think 4 times or so, you'll find a question that's not super weird, that's not like it feels very much in distribution when you look at it, and the model will get it wrong. So I'm quite intrigued that what is it about this test set where it is 80%, but at the same time, when you just kind of try other questions, you can find it somewhat easily on the same set of images on Coco. And so it might be that maybe these questions are like, to me, they seem like these adversarial questions are within distribution, but there's something about the ones in the VQA data set that are just easier somehow. And so, yeah, when you interact with the models, it's clear that the problem is far from solved, even on Coco images and like all of those things. So yeah, even like setting aside all of AI, even in the context of VQA, I feel like the problem isn't as solved as 80% might suggest. Yeah.
Well, but you just said you need to try 4 or 5 times, so that's about 80%, right?
That's true. That is true. Yeah, that's true. That's true. Yeah, that's true. I don't have anything more to say other than that. That's true. I would, yeah, in my head, somehow 80%. I guess the issue is that I'm comparing 80% to the 83% interhuman agreement. And that's why I keep, like, I'm not thinking of the gap as like 1/5 of whatever. I'm thinking of it as significantly tinier. But even in these adversarial questions, there is going to be interhuman disagreement. So the 100% bar isn't there either. And so maybe, yeah, 80% just indicates that 1 in 4, 1 in 5 times. Yeah, that's a good point.
Adverse question. So I wonder, do you plan to have more dynamic benchmarks where humans or crowd workers will directly poke the model and evaluate the performance?
This is where it's headed. So this is, you probably know of Dave Kila's like Dynabench work in adversarial NLI and so on. And so this, what I'm describing, is in collaboration with him. So it's coming very much from that same philosophy. And at the same time, other researchers, I think they're at Microsoft, also did exactly this adversarial VQA, where they've collected data with a model in the loop. And so it does seem to be on people's minds in general. Yeah.
Yeah, or I guess the other option is to do it in more interactive setting where you have embodied agents interacting with people.
Yeah, those agents are really bad right now. once they are able to do something, we'll put humans in charge.
Okay, cool. So I guess I'll start. Hi, everyone. Welcome to the second live panel for the VQA workshop. I am Ayush Srivastav. I just finished my master's from Georgia Tech. I will start my PhD at University of Michigan this fall. I will be moderating this panel today. Before we proceed, a few quick notes. We will be recording this panel so that those who couldn't join us due to time zone differences and such can watch it later. We will be posting these recorded panels on our external website. Everyone except panelists, please keep yourself muted. Panelists, please feel free to interrupt or speak at any point. We encourage the audience members to ask questions. This is your opportunity to interact with the speakers. In order to ask a question, please either type the question or mention that you have a question in the chat box, and we will call your names in a sequential fashion. You can then unmute yourself and ask the question yourself. It would be great if folks can keep their videos on, considering they are comfortable doing that. So let's get started. We have 5 panelists in this session. All of them are also invited speakers at our workshop. And if you haven't watched their talks already, please do so to learn more about their work. So today on the panel, we are excited to have Justin Johnson, who is an assistant professor at the University of Michigan and a visiting scientist at Facebook AI Research. He is broadly interested in computer vision and machine learning. His research focuses on visual learning, vision and language, image generation, and 3D reasoning using deep neural nets. In his talk, he speaks about learning visual representation from language. Then we have Her, who is an assistant professor of computer science and data science at New York University. Her recent research directions focus on text generation, robust language understanding, and dialogue systems. In her talk, she speaks about overcoming the language barrier in VQA. Next, we have Mohit Bansal, who is an associate professor in the CS department at University of North Carolina, Chapel Hill. His research interests are statistical natural language processing and machine learning, with the focus on multimodal, grounded, and embodied semantics, and also human-like language generation and dialogue, and interpretable and generalizable deep learning. In his talk, he speaks about knowledgeable and spatio-temporal vision and language. Next, we have Katerina Freg-Tiarki, who is an assistant professor in the machine learning department at Carnegie Mellon University. She is interested in building machines that understand the stories that videos portray, and inversely, in using videos to teach machines about the world. In her talk at the workshop, she speaks about visual question answering with 3D visual feature representations. And finally, we have Anirudh Kaul, who is an AI scientist at Pinterest. He is known as the founder of Seeing AI, the most used assistive technology by the blind community after the iPhone. He has been pushing ideas to reality using computer vision and deep learning techniques for augmented reality, robotics, speech, productivity, and as well as building tools for communities with visual, hearing, and mobility impairments. In his talk, he speaks about how AI can empower the blind community. So let's get started. So does anybody from the audience wants to ask the first question? Yeah, Shashank, go ahead.
Hi. Hi, Justin. This question is directed at you because I got this question after looking at your RedCap's work. So what I found was the captions were of very high quality and the whole work looked pretty interesting. But one thing I thought was whenever we collect images from user forums, there's an intrinsic distribution in the data. For example, pictures might be perfectly well lit in ideal conditions. So what are your thoughts on building models which consume such perfect data but would have to work in the wild? Is there like a subreddit for not so perfect pictures, or how would we go forward about it?
Yeah, I think, of course, all data sets have bias, and you're going to do the best if the type of data you want to work on at the end is the same as the type of data you train on. So I think it's a little bit futile to try and build the one Uber data set that's going to contain everything, because there's always going to be some distribution of that data that might not match the distribution in some downstream tasks. So I think it's always important to have a lot of different sorts of data sets out there that you can learn from. And within that idea, I think one appealing thing about Reddit as a data source is that you can kind of see it as a collection of independent data sets captured from different subreddits. So we chose a particular set of subreddits for this initial RedCap's work, but different subreddits have their own data distributions, their own community standards, their own types of images, their own types of language. So that gives you a kind of some built-in distribution of different types of data to learn from. I think also that it's user uploads and it's anonymous. It's a little bit different than the more photo shoot style images you tend to see on like Instagram. So I don't think it's perfect, but I do think that it's maybe closer to in the wild type of images than other sources of data.
Thank you.
Because Justin has the mic, I have a follow-up question. So you use vision and language supervision to train and learn visual representations as opposed to classification labels, right? So I wondered, like, you have a sense for how the annotators felt these two different tasks were different in terms of the ease of annotation or the cognitive overload or the annotation time it actually takes to select a label versus writing a description, and the naturalness of the whole annotation pipeline. So that was one question. The second question is, like, how do we, is there a bias here where we usually tend to describe the most salient objects in the scene, and then whereas classification labels are a little bit more curated, so you can kind of look at this, like capture the spectrum and capture the tail. And do we run the risk of not having these, having a good spectrum of visual concepts while using just vision plus language pre-training?
Yeah, I think those are both really important concepts. So the first one is about maybe the ease of data acquisition. I think when we first had ImageNet, the goal of ImageNet was not to be used for pre-training, right? The original goal of ImageNet was, let's use this to learn a system that can classify a bunch of concepts, and therefore that will itself be a useful end task for computer vision. And it was only later that we found out, sort of by surprise almost, that it was so good for transfer learning and pre-training. So then I think then we want to revisit this, and with work like REDCaps and GCC and others, it's almost revisiting, like thinking about the end task and the pre-training task as separate entities, and thinking like whatever task you're going to do at the end of the day, be it classification or detection or whatever, you should collect your own data set that's in the distribution you want to recognize with the category labels you want to recognize. I don't think you can really get around that. But because we know that pre-training is such a useful thing in general, we should think about what's the best form of data to use for pre-training. And among all the types of pre-training that I can think of, I think vision and language is the most appealing, right? Because like, you're just not going to find classification labels for free out there online. And if you do, like the closest you're going to get is Instagram hashtags, Flickr hashtags. And people have tried working on those and are very noisy and very hard to scale up. But language is ubiquitous, and almost any time that you see a piece of an image or a video on the web or collected by a person, there's going to be some language next to it. So that's built-in semantic dense supervision that we can get at very low cost. So whether you're scraping or whether you're asking people to annotate, language is just such a fundamental way that humans communicate that it's really easy to scale up that sort of data. Now, to your second question about bias, yes, of course, there's always going to be bias in any data source, and REDCaps is no exception. It's definitely biased in many ways. And again, I think that's, again, we want to separate the notion of pre-training from the notion of downstream evaluation. And for the downstream task that you eventually care about, you should strive to, I think, build at least an evaluation set that is as unbiased as possible, given the constraints that are actually necessary for the task you're trying to solve. So we're not claiming that REDCaps is unbiased or perfect in any way, just that among the mechanisms we have for pre-training, I think that vision and language, and especially vision and language from Reddit, feels like the best of all the bad options that we have.
Yeah, got it. I think it'd be interesting to see if we can like maybe count the hybrid, or like see if these both sources have complementary semantics that we can capture. That should be interesting. Yeah, thank you.
And I think another thing that people don't realize when they haven't tried to collect their own data sets is that the set of classification labels does not come for free, right? Whenever you're building a data set, especially a data set with a deliberate semantic hierarchy, there's a ton of work and energy and effort on the annotator side that goes into deciding what are the set of categories and concepts that we should have. Are they mutually exclusive? Are they not? What are the precise definitions for all those categories? And then how do we communicate all of those definitions to the users, to the annotators that will be annotating? And that's a huge overhead and a huge burden that I think is pretty underappreciated in the community, because the number of people using data sets versus the number of people building data sets is so imbalanced. So I think that pain of building a semantic hierarchy and defining it and communicating it is lost on a lot of people. And a lot of that goes away with language.
Got it. Yeah. Thank you.
Does anybody have anything to add to this conversation? Any of the other panelists?
I can take a stab at a question that I was thinking about. So it's, and I'll ask Mohit and Justin about it. And it's a question of legality. You both have collected amazing data sets all the way from recording, getting Big Bang Theory transcribed all the way to Reddit. And in one of those cases, it's like a proper copyrighted data source, whereas on the other, it's like open on the internet. So when ImageNet was being used or taken, or COCO, that was usually Creative Commons put up on Flickr by the photographer, usually, at least for the case of Coco. So how do you go around the world of doing the good, but also making sure the, like what can be a learning that can come from your journeys on releasing data sets?
Justin, do you want to continue or should I take a stab?
Why don't you go for it?
Yeah, so for, I think for the video data sets, it is tricky. Like you said, if we, I mean, so the reason for using things like TV shows, the advantage of using them is that they capture a lot of day-to-day activities, right? That involve several agents or several actors, right? And several types of interactions, conversations, activities. And then it also gives you a wide variety of genres in terms of medical conversations and events, crime events, sitcoms, which basically represents a lot of events in daily life. And then in terms of being able to, or like the legal side of it, we basically for now are following the usual norms where we are doing fair right use for things like only using short enough clips of these videos that cannot reproduce the full episode, and also only and even one step further of only providing maybe the latest video features as representations for these frames, as opposed to maybe even the original frames. But yes, I mean, I think the point you're getting at is it would be great to have the best of both worlds, right? Where we could really take advantage of these sources of information, but also in a way where we can be more freely sharing information while also being, I guess this connects more to the internet usage of things also. I mean, that's a different angle, right? Where are you misrepresenting people, or are you like leaking private information? But I think at least from the TV show side of things, I would rather have more openness here and like less copyright side, as opposed to being constrained to only, like for example, one of the open challenges on the video and language side would be, as I ended my talk in one of the conclusions or next steps, is long distance understanding, right? So most of the current models and data sets are focused on short-term question answering, even inside videos. But we need to build agents that can answer questions like, why did Ross and Rachel break up, right? I mean, things that, for example, can look at not just one video, but across episodes, across events in life, and be able to do multi-hop reasoning like we do in documents, right? Be able to connect things like multi-moment retrieval in some sense. And then also after retrieving those multiple moments with gaps, being able to collect all that information, assimilate it, and then give a also generative answer and not just a classification answer. So there's a lot of things left to do, but the constraints that come with some of these data sets will obviously be at odds with what, I mean, I wish I could go and also record new like realistic TV shows, but that, I guess that's one direction. But yeah, so hopefully that answers part of your question.
Yeah, first off, spoiler alert. Come on, you got to warn us before you drop bombs like that.
Yeah, maybe they're on a break. Who knows?
But yeah, more seriously, I think this is something we've thought about a lot and talked about a lot whenever you're building a new data set. So there's a couple standard answers, and one is that, you know, the legal side, we're not lawyers. There's been very little case law actually deciding a lot of these cases, so I don't really want to say what is the legal side of things. But a standard cop-out that other data sets have used and that we use in REDCaps is not redistributing images at all, right? We only distribute links to images, and there's no leakage of private information because it's all stuff that was up there on the web publicly already. Now, there are a couple downsides to that approach. One is that the data evaporates over time, right? This is both a feature and a bug, I think. It's bad for reproducible science because it means that the version of REDCaps that someone works on today is going to be slightly different from the version that someone can download a year from now. And that's something we've been reckoning with conceptual captions for a couple of years now. But I think that's a thing we need to deal with because there's a privacy and a consent issue that we just can't get around otherwise. So I think that that's the right call for this sort of data. But more generally speaking, I don't think there is a good solution to this right now. And I think we're kind of in for a bit of a reckoning as a field as to like, what is the right source of data? How are we supposed to get it? How are we supposed to train on it? Because I think people are starting to realize in the last 5 to 10 years that there's great economic value in data. And this is something that people didn't realize 5, 10, 20 years ago as they were creating all this content and putting it up on the web for free. So I think, I'm not sure what the answer is, but I could imagine that in the future, we'll need to create data for the specific purpose of pre-training or training or evaluation or whatever, rather than trying to take stuff that just happened to be up online for free. I think that's gonna get us along for a while, but at some point we'll have to start creating data for the specific purpose of training. And that's gonna be expensive, but I don't really see a good way around it.
Thank you.
Can I add something to that? I think like both of you mentioned, and all three of you mentioned legal aspects of it and the fact that Justin said there isn't much case law, but some of it is an extra legal consideration of people's expectation. Like people put, if you read the article that came out in New York Times after IBM's data set, the people described that in 2004, somebody put a picture up of their family and their kids, and that made its way into that data set and it was used. And what they say now is that they never consented to machine learning systems for that data to be used to train face recognition systems. And they feel that that they did not give informed consent to that decision, which is a reasonable stand you can take. Even though the license is Creative Commons, it's just our understanding of, or that person's understanding of that license is different today. And if they had to make that decision today, they would not put it into that license. And what that means is, as a research community, we can no longer get away with what we could get away with a decade ago because people's understanding of those licenses were different. And I wonder, like, I imagine this is a good thing. Like we have interesting problems to solve. Like people are looking at, like, how do you prove that when you can delete an example from a training data set, that you update a model, that you can prove that now these new weights cannot give you any information about the sample that was just deleted. And then there's like the extra technology, like the social implication of this, that maybe there are entire professions will emerge whose sole job is, just like we have, zookeepers who train animals, there'll be professions where their job is to generate the right kind of environments in the data sets to train machine learning systems as black boxes. And maybe there's an economic system that will emerge where you contribute a sample and that sample has a token associated with it. And every time that shows up in a ML system that's trained, you get a percentage of the value that's derived from it. And there's some interesting systems to be built there.
By the way, this was a great discussion from Monica and Rachel, the zookeeper. I would imagine that for some of the companies who own data like Getty, they have an amazing business opportunity to give their data sets to companies for training because they have done the work, for years. So it kind of comes as an opportunity for some of these companies who just happen to be in the business of doing things, and AI came along. It's like 450 million images with captions written by professionals. Are pretty neat.
Another point on the licenses that's kind of sticky is that the Creative Commons and the license and the ownership of the image belongs to the photographer, generally the person who took it. But the person appearing in the image might not even realize that they appear in an image at all, and might not have agreed to appear in a photo, or had no say on the license or the usage of that image. So even just looking at licensing, right, you could argue it's more harmful to the person appearing in the image who might not be the photographer.
I think one potential downside of having people or crowd workers to create images is that it's very specific. For example, the photos taken by photographers are probably very different from images we want to use, for example, to help blind people, where you're seeing things from the egocentric view. So there's also this distribution shift issues that we might want to handle.
But maybe based on this comment, maybe it's not that hard to tell Amazon Mechanical Turkers to actually, generate egocentric data where you go to the supermarket, and right. So you just ask your Turkers not to annotate the data, but to generate them based on the topic and yeah, and get them for you, I suppose. Or just buy garlic, for example. Maybe you have a problem with garlic. I don't know, something like that. Like
I guess the part always bothered me is like the person going to the grocery store is okay, but what about the checkout clerk? What about all the other people at the store? Like they're not necessarily okay with that.
yeah, but we can blur their faces because face recognition works.
Yeah, I think there was a data set sort of like that. I think Abhinav Gupta was involved in it. I forget who the authors were or what the name was, but they had people on
Hollywood
mechanical.
Films. Yeah, charades is this.
Yeah, exactly. Charades.
Yeah,
Charades. Yeah, exactly.
Did they study some sort of potential distribution differences or like some sort of lack of naturalness that might happen in such data sets, or it was pretty close to other more natural data sets?
Yeah, great question. So there, the person that was doing the activity would choose the viewpoint. So let's say they say, show me how you swipe the floor. So they had to select, they would take their mobile phones, put it somewhere. So of course, depending on where they put it, there is a bias. But you can guide them even more. You say, make sure you put the camera there under this angle and so on. I'm not sure. I think that is a good solution to specifically ask for data that you need.
Yes, interesting.
So in many examples for when you're productionizing an API, so when we are trying to fight on an academic benchmark, we might have a taxonomy of 600 items. But in examples of for blind users, the taxonomy in real life for them to actually depend on an AI solution is like much larger. So having the taxonomy and accuracy you currently have, and then like what is the list that you really need to nail down? For that, you have to actually send workers in, you get a contractor, send them in real people's homes to take the images and actually take them in a very cluttered environment where it makes it hard and messy to be recognized. So yeah, you have to send people in real life situations to find things which would be really, really cluttered.
Yeah, I think there's some interesting sort of parallel here that from the language side, right? If I'm trying to think of the same thing that we would do in NLP, maybe it's much harder. And also the naturalness or the distribution difference that Hehe was also mentioning, right? I think that will be much bigger, right? Because annotations like answering questions or technically even writing summaries are the annotation side. But in this case, the parallel to taking images would be to writing certain kinds of documents for us, maybe, right? Like which have this kind of maybe topic or this sentiment or this kind of interaction going on in the document. So I could sort of expect some interesting naturalness shifts, right? Where like they're sort of consciously writing something for you as opposed to an originally naturally occurring document that was for that aspect.
I think that's where Grammarly wins in data.
Okay, but now we get an interesting failure mode, right? Because now you're asking people to generate images or generate documents for you for the purpose of training, which means that you're going to make so many of them that nobody's going to look at them all. And any one of them, you don't really care about the quality. So as a rational worker, what are you to do? Well, you're probably going to download GPT-3 and get samples from there, right? And then how do we avoid that situation?
And that's been an old problem for years for the machine translation community. I mean, in some sense, there's always been GPT-3 for machine translation, right? I mean, I'll not maybe give advertisements to companies, but yeah, XYZ translation engines, right? And so there's a lot of work from the machine translation community when they collect data on all these measures that you're supposed to take for annotators to not be just copying from a translation engine. So yeah, so that's a good point.
So often there's a validator level. So if you, let's say, go with an agency who's trying to collect data for you purposely for this, so they have the data collectors, but then they also have the data validators, totally two different places. And that helps in that specific scenario.
Yeah, also to follow up the Justin's point, I guess another possibility is instead of asking workers to creating data from scratch, which could give them a natural raw image and ask workers to edit it so that it could hide the original sensitive information.
Okay, so if there's nothing else to add to this conversation, let's move on to the next question. So Yash has a question for her. Do you want to go ahead, Yash?
Sure. Hey, thanks for your amazing talk. Like while I was going through it, I noticed that you have this approach called drift, where you kind of turn off gradients of some samples that make the data set biased. And then what happens due to that is that you essentially improve robustness of your models, but then you also drop their in-domain accuracy. And that made me question, like, what about metrics? Like, is in-domain metrics the only way to evaluate a model? Because, I mean, like, shouldn't we consider robustness as some form of metric? We are trying to push this accuracy every time, everywhere. But what about its robustness? What about these things? Shouldn't we like have a metric for that as well?
Yeah, I think people are starting to think more about the evaluation, like David mentioned at the beginning, that the in-distribution accuracy is pretty high for VQA, but if you test on adversary examples, it's not satisfactory at all. So I think there are many different proposals. So one is you look at both the average accuracy on all distributions and the worst case accuracy, like on some challenge data sets, for example. And the other is to look at invariance, like in invariant risk minimization. So the point is you want the average accuracy to be high, but you also want the accuracy to be similar across different distributions of groups. I think this notion is also related to the fairness. I think another thing is also what David mentioned at the beginning, where you could have a dynamic benchmark where once you release the model, instead of testing on a static data set, you ask people to poke the model and see what are the potential pitfalls in this model.
That makes sense, yeah.
Yeah, overall, I do agree that we need to move away from the static leaderboards.
Thank you.
Okay, so yeah, we can move on to the next question. Shashank has a question for Anirudh. Go ahead, Shashank.
Yeah, hi Anirudh. Following up on your earlier comment on how the number of classes needed for real life classification is much higher. I also had this question on when you're building apps like Seeing AI, there's a fairly good chance that the ML algorithms are misclassifying an object. So did you face this concern? And if yes, what kind of algorithms or even technical solutions such as visual interfaces or something that you have come up with to tackle this particular problem?
Yeah, absolutely. So I think while building some of these apps, you have to maybe go more towards like what's the user need than trying to fit like you have a cool AI technology and let's just fit it in. So one simple example which kind of fails totally is like we thought, hey, we should have a God mode where you keep an object in front and it'll just tell you what this is. But maybe the user is interested in reading the text, or maybe they are trying to discover like where the edges of something are. Like there can be multiple intended reasons. So no matter what we think, it's like you have to ask the user, like, what are you really trying to achieve there? The second part being the example of what it recognizes is not actually even accurate, right? In image captioning, it will be even worse off than just image recognition, for example, right? So one thing we learned is that really try to give low expectations to the user. It's an experimentation mode. It's work in progress. It's like a 3-year-old, use all those phrases. So really keep the expectation low. And what we found is when people started using it, their comment was, when it works, it's magical. That was the first comment. Then they said, I have become an explorer. And they figured out when to depend on the system And when they actually started learning that what are the common error cases for which it doesn't work. And they started to rely on like when it works and when it doesn't work. We had the most crazy story where after hurricane in Puerto Rico, a professor who was sort of lost took the photograph and took a photograph at a location he knew kind of where this was. And it said a bridge over, it said a muddy field. It used to say a bridge over a body of water because in the hurricane, the bridge had actually flown away during the hurricane. And using the human intelligence and what the captions are saying, the person would kind of make sense of like what it means when it needs to say something, even if it wasn't always in the vocabulary. So people know they can't completely rely on it, but they also know at what moments, what times it can. Another good example is classification has a much larger vocabulary than object detection. So when we are releasing things to production, we can't fit everything on the mobile device. So we had to initially do it on the cloud. And for classification labels, even though it can recognize enough, captioning it is like much lower text, like full sentence captions that can be built. And similarly, object detection is much smaller in numbers. So we had to constantly like be pushing towards how we can keep pulling more taxonomy at higher accuracy, at higher metrics to go out. So now people would take a phone and they can hear a general idea of what are things underneath something. And the moment they would go towards the next level, like, okay, I want to understand the spatial understanding of the scene and go towards object detection, it's not saying the same words that the caption just told you. So those are like the common failure examples, but they kind of, get like, yeah, it's work in progress. Another example was last year, iPhone 12 Pro came out, and the technology that came out with it was the LiDARs. And now what you could do is like you can actually move your phone and it will do a 3D depth sensing, and then you put a 2D object detection back into the 3D world and raycast it. And like here's where the object is, but there's certain things which are away from the LiDAR, right? Which is like, more than 4 meters away from you. And it can't capture the general depth of like that side of things. And so people would like, why is certain thing not being able to be like recognized, but then when I get close enough, it does. So those are like the kind of examples that people, once they start using it, they learn it. But one small, nice little thing that we learned was in the UX, when you say something, you say the words like probably before you say the sentence, or like, this is XYZ. This probably is XYZ. And in certain cases, don't even say if it's like bad. In other examples like currency, you just cannot say something wrong. Like you have to be like 0.99 or higher, in your metrics. So we trained it with a bunch of adversarial examples, and we taught it when not to speak things. So it kind of knows what this is, but it just shuts its mouth. And hopefully in the coming frames, there is an opportunity to see a frame which is non-blurry, and it can just speak things out. Rant over.
No, that was a pretty interesting list of anecdotes. Thank you for sharing.
Thanks.
So on your UX idea of adding the image may contain or adding a little bit of uncertainty to the caption, one of the interesting things we found in the REDCap's data analysis is that one of the most common trigrams in Google conceptual captions is image may contain. So that makes me think that actually a lot of the captions in there are probably auto-generated anyway, which leads us back to this GPT-3 problem from earlier.
I had just a quick anecdote. So about a decade back, there was all this effort in question answering, like before the vision part came in. And a lot of the trick-based question, like systems were based on, hey, here's a question about which NFL player has done XYZ, and the document set is Wikipedia. That was like the premise. But then these questions, other researchers would start posting it on the internet. And so when people would say, okay, maybe we can use redundancy on the internet to try to answer it, and they'll see the exact same question and the answer right underneath it. So a good research solution ended up becoming data leakage here.
Okay, so we can move on to the next question. Satvik has a question from Mohan.
Yeah. Hey, Mohit, thanks for the talk. So I think at some point, we need to take all these models, which are specialized in individual tasks, and put them together, and then potentially have it, give it the capability to like answer any of these tasks. So related to that, your VLT5 work, I was curious to know if there were any like challenges, modeling challenges that you faced, or did your formulation just work out of the box, or were there any engineering tricks that went into that could potentially benefit the larger crowd, and then we could have like some good takeaways from there?
Yeah, no, tons of engineering tricks, and I mean, so maybe I'm not the right person to answer about all the engineering tricks, but the paper, we did make sure that the paper does actually have a long appendix and supplementary on all the tricks. But I guess at a high level, some of the main things we took away were that so the goal, just maybe for people who've not seen that part of the talk, is that it's a unified model that basically takes discriminative, generative, and then also vision and language tasks that are about grounding versus question answering versus captioning. How can we have a single framework that answers all of these? And the way to do, or one way to do that was where we treated that as a autoregressive encoder decoder model, like so treating all of these as text generation. So you would have the task head as like one of the prompts, and then the textual part of the input, the visual part of the input, and then this would be the all the encodings, and then the decoder would try to generate all types of task answers. It could be obviously captions or question answers, answers to questions, but also things like the grounding ID of the bounding box or multimodal fill in the blanks kind of things. Yeah, so I think some of the challenges there, for example, were that it's very, so there's two goals there, right? If you're doing multitask learning, ideally you would be able to have some model that's doing all of these together. So basically the goal was not to improve the accuracy over all the individual tasks, right? That sort of like maybe was our initial expectation, but then, I mean, that was a little bit unrealistic because you are trying to more have a single P parameter model as opposed to 7P, 7 times the parameter model, while being able to achieve the same amount of maybe or almost close to the results of the individual task specific architectures. So that was maybe one of these sort of expectation changes that you need to have, right, when you're building such models. The other thing was that we ended up getting pretty excited about the generalization aspects of this, and it does relate to maybe Anirudh's original question also about number of classification categories. So here, one of the main goals was also that for rare or unseen categories of answers in tasks like VQA, this generative model can handle generating such rare answers much better. So that was the other focus of the paper. And then there were other things about task-specific heads versus like a single head. So yeah, so we've done a lot of ablations, but those were the two main takeaways. One was the expectation of multitask learning as a single model versus there's the other kind of multitask learning where you have a primary task and you're bringing in auxiliary tasks to help this primary task, right? So there you are trying to do better than the task on its own. But if you're building a unified model, it's more about being able to reach the same accuracies of the very specialized individual models, but at only 1/7 of the parameters, maybe, as opposed to all combined. And then the more interesting part to us was the generalization because of the generative model, that you could handle things with more open-ended vocabularies.
Great, thank you.
I have a follow-up question. So I didn't look at the evaluation in detail, but most evaluation I saw are either multimodal applications like VQA or image classification. So I wonder, does it also improve textual applications like just reading comprehension? Yeah, so we've done that for an older paper called Vocanization. This was like in the pre-clip era. So basically, Vocanization was about exactly what you said, where can we use multimodal information to improve text-only tasks. So the idea, I can give a brief summary, but so that also had a couple of very interesting takeaways or challenges that maybe, I don't know if Satvik is interested in that. So Vocanization was the idea that instead of training BERT to basically predict the masked out fill in the blanks, right, as in the general language only task, you're also trying to make it visualize and map to its visual mapping, right? So the textual words should be able to map to their visual mappings as another pre-training task.
But the two big challenges that how the lead author solved here was that one is that such kinds of text to visual mapping data sets are very small, things like MS COCO, but BERT needs to be trained on much larger and also much longer sentence data sets like Wikipedia, which also has a better vocabulary and sentence length and distribution match to what language tasks need. So one was how basically half the work was on how to train a vocanizer, right? This visual mapper on smaller data sets like MS COCO, but then transfer them to get vocans for all of Wikipedia, which can then be used to retrain BERT. And the other was that even with Wikipedia, like the number of words that have a lot of visuality, right? Visualness is a much smaller percentage. So if you want to go from that small percentage to having vocans for many other words, you would do this in a contextual manner so that surrounding words can also learn their visual mappings based on the context. And so then when you get all of this vocan data, you retrain BERT, and then we show improvements on question answering tasks, text-based common sense tasks, and then NLI, MNLI, SNLI, a lot of language tasks there.
Oh yeah, I'll check that out.
Thanks.
Mohit, I have a follow-up question on that paper of organization. So if I remember correctly, like you were trying to map these textual tokens to images, right? And then use that pre-trained model ahead. What happens if things are overlapping in the image? What happens if there are two things, and wouldn't that just cause confusion? Because
sorry, can you say a bit more, like two things in what side?
As in, like, there are two things, like so say there is a bigger bounding box which is like a coffee table, and then there's a smaller bounding box of a cup on it, and I'm just trying to map the text of coffee table. So how will that resolve? Like, there will be an image of the smaller cup inside as well, right?
Yeah. No, so we didn't go into, I mean, the first paper didn't have that level of disambiguation. There's been hopefully there'll be more follow-up work on that. But yeah, I mean, so I think this was sort of the first step to basically get visual mappings. These were not even at the bounding box level. These were actually at the image level. And so there's a lot of hopefully further improvements to be had if you go into the segmentation level, and then there'll be this. I mean, ideally, more information is probably better. Like if I had to make a choice there, I would use the bigger box because at least it'll figure out with other pre-training tasks, right? It can disambiguate through that. But yeah, these are all great things to explore further. Thanks.
Makes sense.
Okay, so let's move to the next question. So Shashank has a question for Katrina.
Yeah, hi Katrina, thanks for the really interesting talk on learning and disentangling 3D representations. So my question is, when we learn implicit 3D representations from language, how do you think neural networks can learn to leverage external knowledge, that is the world knowledge that humans naturally possess? For example, when you say a matchbox is kept beside a water bottle, humans can naturally imagine missing details like the relative sizes, but none of these things are explicitly mentioned in the language as such.
Right. Just to make sure I got correctly your question, can you please tell me again with the example that you said at the end, like the bottle?
Yeah. So if we are giving it a picture of matchbox and a water bottle, and if we are saying it as a matchbox is kept beside the water bottle, humans can naturally imagine the missing details like the sizes. They know that the water bottle is large and matchbox is small because of the world knowledge.
Right.
But yeah.
Great. Yeah. So that's a great question. How do we endow humans and machines with the common sense that humans have? Yeah, so first of all, size is very easy to get if you either move or you have a depth sensor. So just this is very important information. In fact, I mean, Tom Mitchell, who works on language meaning from brain recordings, has said that when you tell people, let's say, trash can, you can decode from the brain, activity, the size of the object. All right, so for sure, word embeddings are linked to information such as size and affordability and so on. So size is easy. Do you agree? If you have a depth sensor, or if you just have multi-view and stereo and so on. But beyond size, there are so many other things. Like for example, Mohit just picked up the glass and drank. and so on. And this glass is empty and has things, and there's water in it. And then when he drinks it, there's no more water in the glass, and so on. So all this common sense that you cannot actually easily get from static images annotated with questions and answers. One thing we are trying to do is you have robots exploring, let's say, environments by manipulation. You open doors and drawers and you put things on drawers and so on. And then if you accompany such robot experiences with language, and you are able to build abstractions or future representations that are not very tight to pixels, but actually you can build some abstraction of container that can be reused in other environments, then you can learn from your embodied 3D experience language and groundings that you can use on your non-embodied static image, VQA, for example, right? Now, this is a little bit difficult to realize because it does require that you learn about class and containers in not a pixel accurate way. You cannot just take CNN features and map them to another domain because things are not just going to generalize. So you really need to, have a little bit more higher level of abstraction. But this is one thing we're trying to do to marry, let's say, a 3D, but things you learn on 3D and embodied tasks by moving around and by manipulation to, 2D, let's say, images, static images and videos, and language transcription there.
I see. Got it. Thank you.
Can I ask a follow-up to that?
Yeah, sure.
So hi, in this way, like as you said, like you need to work on a higher level of abstraction of say concepts or sizes or styles or something similar. What I generally see in the literature is that people are trying to build these modular networks with every module trying to, like specialize in predicting or generating one particular sort of thing or one particular type of attribute. Do you think these are scalable? Like, I mean, how many of these modules can be there? And like, how do you decide what modules should be shared and so on?
Yeah. So it doesn't need to be modules, but the truth is the following. So you're asking a great question. Now, this goes back to the following question. What should be the right representations, let's say? And this is what you're asking. What if the representation depends on what you are handling? For example, for the door, it depends on how it's open or closed, right? And that's how when we communicate in language, that's what we describe. And we're not confused. We don't think that the shading changes if the door is open or closed. So clearly humans can do that. Clearly humans can disentangle to death, right? Do you agree? So we can understand when the door opens and closes. We can understand now if you go to the glass, there is no open and close. There's something else there. There is how filled is the glass, okay? And then when you go to another, let's say, for bottle is similar, how filled is the bottle. For drawer, again, it's how open is the drawer, but it looks very different than the door. So what if the state and the future representation depends with what you're handling? For, let's say, this one, again, it depends on how open it is and so on. And the more you explore the world, the more you can save exemplars, let's say, of things that you have manipulated before. And the more abstractions you have to talk about. Do you see? So your label space enriches, the more things you get to know, the more things you experience. So yeah, sure, the modules can grow and grow and grow. But it's correct what you're saying. We should not need to predefine them manually. The agent should define them, right? Each time for example, imagine you go to the Sapiens dataset and you play with the washing machine and you don't know what's the washing machine, but you know about revolute joints and prismatic joints, but you explore one washing machine. It's okay to remember that, oh, there is this thing that has this interesting door and there are these 3 buttons, and now it's an abstraction I'm going to use in the future, right? So, but this is a great question, what you're asking. And so people say that in vision, the input is easy, it's just, the number of pixels, but the output is not clear what it should be. And each one of us, based on our different experiences, there's going to be images that mean different things to us, right? For example, you may recognize the toy of your kid or something that your mother has given you that for the other person is something very generic, right? Because we don't have the same shared experiences. So maybe the agent, as it experiences more and more, it builds more and more things to launch onto and use when it describes the thing or when, it captions it or when it answers questions about it and so on. but yes, it's impossible to predefine everything. This needs to be kind of a automated process that does this. That's why
makes a lot of sense. Yeah.
Yeah.
I mean, like that point of reusing things, and like as you said, like I might not have seen like a washing machine before, but I've seen doors, and washing machine have similar types of doors, and something that gets shared across all of these, and it just grows. Yeah.
Yeah. At least that's what we're pursuing. I mean, God knows if it is going to pan out at the end, right?
Yeah. Yeah.
Okay, so looks like we're out of time. So let's end the session here. Thank you all the panelists for the insightful discussions, and thank you all the participants for joining. We would like to remind everyone that we have a second round of live QA session by challenge winners, challenge hosts, and the poster spotlight presenters at 12 a.m. Pacific time today. So make sure you don't miss that. And lastly, if you haven't watched the recorded talks, I would encourage you to do so. There's a lot of exciting stuff. That's all for this session, and thank you for joining.
Thanks, everyone.
Thank you so much.
Thank you.
Thank you.
Thanks for organizing.
Thank you.
Bye, everyone. Thank you.
Thanks.